Beautiful. I want to welcome everybody to the very first training of this week. And hopefully we will be able to take care of what we have speculated for the week. And we would go right away doing some kind of review and moving forward to hands-on. I want us to talk about deployment and management and to comprehensively look at it. We have lots of AWS services. And for the sake of deployment, we will be looking at Amazon Elastic Beanstalk. And thereafter, we'll introduce microservices. And in microservices, we will take a look at Docker and how it relates microservices. Then we'll go into Docker with a deep dive into Docker. We'll look at Docker and go down to the AWS containerized services. All right, where we'll talk about ECS, EKS, Fargate, and so on and so forth. Okay, having said that, let's kindly have a view over Elastic Beanstalk. Like I said, it's about deployment and management. And Elastic Beanstalk is part of platform as a service and which AWS is offering. With it, cloud practitioners will be able to deploy their codes, manage it, and at the same time scale their web application and services. So with it, code writing and without the requirement to manage infrastructure is made available for us. So Elastic Beanstalk has a kind of architecture that we must understand. Let's take a look at this diagram, this architectural diagram here. We have the Elastic Beanstalk here at the gate. And we want to deploy and scale the web application and services. With Elastic Beanstalk, we'll be able to create an account and answer certain questions as regards the input of our environment. And in the third layer, you see that there is a place for the application code where the application codes can be deployed. Then the platform is there. So we have two things, the platform and also the application code. Yeah. And the last thing, Beanstalk can be integrated with S3 bucket. And then the Amazon EC2, that is when we are required to provision a server. Then also CloudFormation. Codes can be deployed through CloudFormation. And then we can use the Amazon CloudWatch to monitor the various activities that are being carried out. So that's that. And then at the overall, we have the web application server. So let's take a deep dive and see how these services can integrate with one another. Okay, but before we do the hands-on, let's talk about microservices. Microservices is a kind of approach that we cloud engineers would deploy in managing our applications in a decoupled way, in a loosely coupled way. For instance, if we have a large application and want to break it into smaller and more manageable packages, that is what it's all about, by trying to subdivide the larger application into smaller and more manageable packages in a way that they can be loosely coupled. And when they are loosely coupled, it means they can run independently. Peradventure, there's an advent of troubles in an aspect of it. it will not affect the whole application. And that's the whole essence. We would be required to loosely couple our applications. How do you get this done? First of all, you focus on the business and the capability of it, and see how you can segment development, deployment, and so on and so forth. You break them in a different way that each application in the larger scale can be assigned to carry out specific tasks. And also they can scale independently without relying on other aspects of the application. Yeah, that is microservices. So there's something that enables us to be able to carry out microservices, to be able to cascade our applications down to smaller and more manageable way. And that brings us to what is called the Docker. The Docker enables us to create containers and put our applications in a way across these containers. So whatever activity that is happening in a single container would not be affected with other activities taking place in a different container. So like I said, microservice is an architectural approach, yeah, and it's for cloud engineering. And it involves what? Cascading the larger or the monolithic application into a collection of smaller and loosely coupled applications that can, be deployed independently. Okay, so Docker comes in with a containerization technology, which is good for us to use in implementing these microservices. So now let's take a look at about 4 bullet points so we can have an understanding of how Docker works in microservice. We can use the containers now to separate these different services and run independent codes in them. All right? So, but through the APIs, these applications can actually communicate with one another. So, but all applications can run on its own, ensuring that it is decoupled from other services. Yeah. It encourages portability. And when we want to, provision and test just an aspect of our monolithic application, we now know that since that aspect is containerized, we can go straight down there and carry out that test without causing complete downtime of the total application. That is about microservice and what Docker will do for us. So if peradventure there is an increase in demand in a particular aspect of it, the total application will not be spinning up. What would happen? That aspect, that much of it is required of alone, can be scaled up. Let's see Docker. So Docker actually automates the deployment, the scaling, and the management of the application within lightweight portable containers. So you can your catch-up words will be lightweight and portable containers. And every container is independent of the other container, but they can communicate, like I said, through the IPs. A single container should have everything inclusive that should be able to run all the application in it, like the code, the runtime, the system tools, the libraries, and the configurations. Okay, so this enables us to be able to package at the same time distribute applications. So that is about that. And when there's the times that we talk about microservices and we talk about Docker and containerization, virtual machine will come into your head. Are you not sure you're talking about, like some questions I get from the students, they'll say, are you not talking about virtual machines? Because some of them could have been familiar with virtual machines before coming in to learn Docker or containerization. They are similar, but from the architecture which we have here, you should be able to ascertain. Let's take a look at the difference. All right, just hold on. Let's take a look at the difference of it. You see that the Docker is a kind of a virtualization technology, but it's not specifically virtualization. Resources are actually shared with the host, unlike that of the virtual machine. Now, look at the virtual machine's configuration. You have the infrastructure here at the line at the bottom of it, and the infrastructure is hosting the operating system, which you have the hypervisor. The hypervisor is the virtual machine. The hypervisor is what is required to cause this virtualization. This is an operating system, a physical server. When you're being able to use a physical server to spin up thousands or millions of virtual servers, you are virtualizing, you're talking about virtualization. You have just one single host of operating system. Now the hypervisor comes in, and through that single host, single physical server, is being able to create multiple virtual machines. Can you see that? And on these virtual machines, what happens? The apps can be run on them. Very simple, right? Similar thing happens with Docker. The infrastructure is here at the bottom line, same the way it is in the virtualization aspect of it. Then we have the operating system, for instance, EC2 instances. Then the Docker daemon is on the operating system, just the way we have the hypervisor on this other side. The Docker daemon is what is being used to create the different varying containers. And once the varying containers are being placed, once the Docker daemon is being able to spin up this container, now Docker can be, provisioned seamlessly in those various containers. And that's why we have this diagram now coming in. You can see Docker on either each containers coming in, right? And this enables us to independently deploy applications, run them in a way that when something happens, they will not create an impact in the next one. Yeah. Let's just take a look at another analogy. We have a Docker file here. The Docker file is built, and we get the Docker image. The Docker image can be, can be deployed on a container like we talked about. And the language that is being used here, you can see that is Python. But now the Docker image can go through the repository. It can push. It pushes down to the Docker hub. All right. While through the Amazon container registry, it pulls to the Docker image. You will understand this better as we graduate. So that's about that. Let's take a look at what is next. On the AWS platform, for us to manage Docker or Docker containers management on AWS, we must be conversant with these things. One, the ECS, that is the Amazon Elastic Container Service. Then, two, Amazon Elastic Kubernetes Service. 3, AWS Fargate. And finally, the ECRO, Amazon Elastic Container Registry. That is that. So I want us to take a look at them so we can have a theoretical knowledge of them before we now start provisioning them. So the ECS is a fully managed container orchestration service. And this simplifies the deployment, the management, and the scaling of this containers application. But now it's strictly for AWS. That is the ECS, Amazon Elastic Container Services. It's Amazon's baby. That's how Amazon sets out to run containerization. Taking a look at the diagram, you have the developers here. And the developers have gone ahead to describe the application and the resources it needs. And it's been deployed to let the ECS do its work. At the same time, the operators can create custom scaling and capacity rules. And same can still be deployed to the Amazon Elastic Container Service. And through it, two things can happen. The configuration aspect of it is there, and the deployment aspect of it. Through the deployment, we can talk about the scaling. In the configuration aspect of it, we will take a look at the Elastic Load Balancer, how the loads can be balanced, and also the EFS and the secret manager. This is how we can automate integration with other AWS services. With these three, whenever you're being asked to talk about how automation can be carried out, you now ensure that you have these three being balanced. So this is on the configuration aspect of it. Then in the deployment, we have the Fargate, and we have the Amazon EC2. We have the Amazon ECS, and lots of others. The wavelength is there, the local zone. But now I want you to pick just two things, the Fargate and the Amazon EC2. For every single deployment from the ECS, is either you would use the Fargate or the EC2. If you're using the EC2, which means your servers will be created. But the Fargate aspect of it is serverless. Amazon, you're not going to be managing servers. Everything would be done seamlessly. And everything is placed on the head of AWS. So these are the two things that we're going to be concentrating at as we make our decisions of what to do. Yeah. Next in line is the Elastic Kubernetes service. We now know that Kubernetes is an open source service. But Amazon came up with a way that Kubernetes can be integrated with the AWS cloud and on-premise data centers. That is why they came up with Amazon Elastic Kubernetes Service. For everything that is in the open source, Amazon would want to have its own. And the analogy here is quite simple. This is the Amazon Kubernetes cluster that would be created. And thereafter, what do you think would happen? It's either you want to deploy through the serverless containers that I talked about. So Fargate is the serverless container containerization. Why deploying servers is by using what? Amazon EC2. And you need to have to deploy the worker nodes and the EKS cluster. And once this is being done, the Kubernetes app can now run. Beautiful analogy, beautiful diagram. So always remember, two things can happen. Okay, just like I explained the Fargate, but let's just see how the Fargate diagram would work It's serverless. It's pay as you go, right? So right now, it's compatible with both Amazon Elastic services and what Amazon Elastic Kubernetes service. So these two are two different services that the Fargate options can be used. And remember, the Fargate is serverless. If you're picking the serverless option, that's Fargate becomes your baby. Now, taking a look at this diagram, it's telling us without Fargate, for instance, without Fargate, these are things that you would deploy. You have to build a container image. You would have to define and deploy the EC2 instance. You would have to provision and manage the compute and the memory resources. And also isolate the application in the separate virtual machine. And then you have to run and manage both application and infrastructure. So much work, right? But you will pay for the EC2 instances. But with Fargate option, straight, with Fargate builds the container image for you, define the memory and the compute resources required. You run and manage the application, call seamlessly. So you pay for requested compute resources when used, application isolation by design. So that's about that. Just think about these two things. EC2s are not created. You can't find instances created in the Fargate, but without Fargate, EC2s would be created. Okay, now what is the Amazon Elastic Container Registry? It's a fully managed container registry offering high-performance hosting, so you can reliably deploy application images and artifacts anywhere. Anywhere. You can run containers by pulling images anywhere. And with this registry, you now know that there's a way to bring in Kubernetes and ECS. The first thing is to write the code as a Docker image. You deploy the Amazon ECR, and the code can be depressed, encrypted, controlled, and can be versioned also. All right. So this brings us to the theoretical aspect of it, where I think we have to go and see the platforms and how we can get familiar with everything that is in there. So which should we start with? Okay, I could have loved to start with the Beanstalk, but the Beanstalk is a little bit longer in provisioning. So let's take a look at the ECS and how we would be able to create a cluster, and then services. From there, we'll go to EKS and do little hands-on on them and touch the Beanstalk. Then we call it a day. Beautiful. Oh, where's my screen? Okay. All right. Elastic Container Services. When we start working on projects, lots of all these will come to life. That's why I would say after our classes, go and see other videos, learn more, all right? And so you can improve on your knowledges. So we are actually at the expensive money zone, okay? For everything that you can provision here, you should have your dollar right on top of your laptop. But we'll see what we can do for the ones that we can afford. When we explain, we will create. For the ones that we cannot afford, we will explain and we will not press the create button. Okay? So you see, from this dashboard, from the get-go, you can see that it's either they're giving you the price of Fargate, they're giving you the price of creating an EC2 and creating what? An Amazon ECS anywhere. So they are deploying the registry here now for you. Can you see that? So let's get into cluster and see how we can create a cluster. It's a containerized services, so clusters must be created. So you create the cluster by hitting that. You give it a name. You say demo cluster. Let me check who is in the house. If my friends are here. So no, Chukuma is here, but Chukuma is not my friend today. I'm gonna go with Steven rather. So let's say Steven. No, let's use lowercase.
Yeah, I'm here. I'm here.
All right.
I'm
so
just.
You're the man of the day. You're the man of the day. So Steven demo cluster is what we have there. Can you see? They said there can be maximum of 250 characters. All right. So if you have names that are longer than my names, then include it. The next thing is for us to go right into the networking. And in AWS, when we talk about VPC, subnetting, security groups, and we are talking about what? Networking. That's the network aspect. There's a default VPC already taken. A subnet is chosen, a default subnet is chosen. Okay. We do clean up every day. All right. So what else? We go to now where we have to make our decision. Fargate the serverless option, the pay-as-you-go. Say use if you have tiny batch or burst workload or for zero maintenance overhead. That's what you need. You not pick this. Or you go with this. Can you see that? If we're creating EC2s, instances to run it, we have to create the auto-scaling group. It's a create an auto-scaling group. That may require us, first of all, let's say we pick the operating system, Amazon Linux 2, which we have always used. Let's say Amazon Linux 2. The instance type. For the free tier, we like T2 micro, right? Let's see if today we have T1. Oh, there's T1 micro. Something smaller, but let's go with our T2. The T2 micro is a free tier eligible. So we pick it. There is no key here, SSH key pair. If it was there, we could have taken it. So we can SSH into our instances, right? We have to keep things simple. We have to now specify the desired capacity. And we want to say 1 as the minimum. So now take a look at this list. They say monitoring, which is optional. When you see monitor, what comes into your mind? We talked about monitoring. Let's see. It said use container insight. But we don't want to do that. When you use container insight, what will happen? You can use CloudWatch automatically collect metrics for many resources. Now, you talk about monitoring, you're thinking of CloudWatch and CloudTrails. But now when you move away from just monitoring, and you go down to compliance and API control, you now start talking about CloudTrails specifically. Okay, so we leave everything the way it is. And now we say create. You have created. The next thing is for you to create the services. It's for us to create the services. Let me create. Later I will send the bill to every one of you so you can be part of it. My network is so beautiful. It takes time to dance first before he would do your command. Great network. Yeah, for you to create the services, the very first thing you would do is to define the task, is to go into task definition.